Back in December, London's Natural History Museum unveiled an amazing 150-million-year-old Stegosaurus fossil named Sophie. Standing proudly in the museum's Earth Hall, Sophie is a big attraction for visitors. But that's not the only thing that's big about her, as I discovered when I went to meet the researcher who's dedicated the past year to studying Sophie's skeleton, Charlotte Brassey. So we're here in the Natural History Museum, lots of people around us, and this beautiful skeleton here. Introduce me to this lady.
So this is Sophie the Stegosaurus, and she is 155 million years old. She's come all the way from Wyoming in the US, and she is arguably the most complete Stegosaurus skeleton ever found.
She looks pretty complete. We've got the spiky plates all over her back, big legs. She's about, I guess, the size of a small van, long neck, head. Are all of those bones that we can see, they were all found with her skeleton?
Yeah, so she's pretty much about 80% complete. So she's missing one of her forelimbs and one of the plates, which we've reconstructed. But the vast majority of it is real. What's particularly exciting about her is the skull. The skull is entirely intact. The one on display is plastic, but we've got the real one in the basement and we're still studying it.
You don't want people poking it around?
It's very precious. It's also still ongoing with studies, so we don't want to have to take it on and off display all the time. And it's also what we say exploded apart, so all the individual little bones that make up the skull are all separate, which means there's about 50 or so bones that would be a nightmare to try and mount up.
When was Sophie found? What was the story of her discovery?
Yeah, so she was found a couple of years ago, and it takes around about a whole year to actually get her out the ground. They went out one summer, found her, realised that it was an important specimen, and then had to go back again the next year to fully excavate her. And then it takes several years of preparation, so she goes back to the lab, and then they work in kind of meticulous detail in chipping off all the rock to prep out the bones like this.
And I have two more fairly obvious questions. One, we've referred to her as she, as Sophie. How do we know it's a female? And also, who got to pick the name?
So, no, we don't know that she's a female. She is named after the eldest daughter of one of our main donors that allowed us to buy the specimen. There are a couple of ways that you could tell the gender of a dinosaur. One way is if you actually slice through the bones, especially in the leg, and you can look at the microstructure of the bones. And in modern birds and in crocodiles, which are what dinosaurs are related to, when the women are ovulating, they put down a certain texture of bone, which then acts as a calcium source for their eggshell. And we actually see that in some fossil dinosaurs as well. But before we purchased Sophie, other scientists had already sliced through her bones and they haven't found this texture bone. So all we can say is that she wasn't ovulating. So it could be a she who wasn't producing eggs, or it could be a boy.
Well, let's go and learn a little bit more about what you've been doing to understand more about what she looked like maybe in the actual flesh. Okay, here we are. So where is this?
So this is our reception of the paleontology stores. At the moment we are on the ground floor, and on the ground floor is where we keep the fossil mammals, so things like mammoths and giant sloths, and we're about to go down to the basement, which is where we keep the dinosaurs.
Let's go look.
Okay, so this is the stores where we keep all the dinosaurs.
Tell me how you're studying Sophie to try and work out a bit more what she looked like in real life.
My background is in computer modelling. So what I've done in the last year has come along and I've created a 3D computer model of every single bone in Sophie's body. And from that we can then begin to estimate things like body mass. We can reconstruct how the muscles would have been placed across her skeleton. We're looking at reconstructing how she would have walked, and also reconstructing the jaw muscles on her skull to look at what she could have eaten.
Obviously, when we see dinosaurs in museums, they are all these bones. Paint me a picture of what you think she might have looked like in the glorious flesh.
Well, the interesting thing about dinosaurs in general is that the group of muscles that they use to pull their leg backwards as they move are very different to what we see in modern mammals. So you can see from Sophie, she's got a very long tail, and she would have had very bulky muscles attaching along her tail onto the back of her legs. And actually, if you go up on our balcony and you look from the top down on Sophie, you see that she's got very, very wide hips. So those two facts combined mean she would have had quite an impressive rear end.
Hefty bulk.
Yes.
How do you start working out how big a Stegosaurus was and maybe how much she weighed?
In the past, people have based it on simple measurements of the leg bones. So typically you would go into a museum collection full of modern animals, so modern mammals and birds and crocodiles, and you would do something like you'd measure the length of the thigh bone or maybe the circumference around the middle of the thigh bone. And then you would also, knowing the body mass of the modern animal, you'd plot that on a simple scatter plot. So you plot body mass against this measure, bone length, say, and you put a straight line through it. And you would then use that line to predict the body mass of fossil animals. So we could then go and measure, say, the length of Sophie's thigh bone or the circumference around the middle of her thigh bone, and use that line on our scatter plot to then back estimate the body mass of Sophie. And that's really useful if all you have in the fossil record are isolated bones. The vast majority of fossil animals that we know of come from very fragmented remains. We don't have the whole skeleton. What's really exceptional about Sophie is that we've got so much of the skeleton. So it seems a shame to be reconstructing her body mass from just these simple measurements alone. We wanted to try and use the whole skeleton. So that's where my computer models come in. So once we've got a computer model of Sophie, I import it into just a simple CAD package like engineers use. And then we can wrap very simple shapes around the 3D object of Sophie. And once we've got a volume for Sophie, we can then look at the relationship between body mass and volume in modern animals, and then use that relationship to estimate her body mass based on the whole skeleton.
And so what do you think? How much do you think she might have weighed? What sort of heft was she on the ground?
So our best guess at the moment is something around 1.6 tons. Which intuitively seems likely to us. If you actually go and look at Sophie on display, she is smaller than an elephant, so you wouldn't be expecting body masses of 3 to 4 tons. She does look something like the size of a rhino, and that's about right for a rhino.
Obviously, animals aren't just the muscles, they're the skin around them. Looking at dinosaurs, they probably were quite protected. Have you factored in those kind of extra bits of weight into this?
Yes, so we've got 3D models of all of Sophie's plates as well. So people in the past have looked at the armour on some of these dinosaurs, stegosaurs, also things like Triceratops with the big frill on its skull and the big nose cones. And they've estimated how much they would have weighed, how much they would add to her body mass, and how it was distributed around the skeleton. And yes, so we factored in the weight of Sophie's plates into consideration. The problem with Sophie's plates is that they're quite squished. So Sophie's a beautiful specimen, she's very, very complete, but she has been flattened in some places. So we've got a volume for her plates, but we think that might be a little bit low because they have been quite flattened.
What do we know about how old she was when she died? Because obviously kids are built on a slightly different scale from adults and they change over a lifetime. Have you taken that into account? And what do we know about how to measure the weight of a dinosaur according to its age?
Yes, so that's really, really important when it comes to Sophie. So there are a couple of ways that you could age a dinosaur. Firstly, based on external appearances. In human children, for example, when a baby's first born, they've got the soft spot on the top of their head. And the reason that's there is because the bones haven't fully fused together. And that also happens in modern species, and it was also happening in dinosaurs. So we can look for evidence in the skeleton of where bones aren't fused together, where we would expect there to be. And in the case of Sophie, she's a mix of features, really. There are some parts where they're obviously fused together, so she looks more adult. There are other parts of her skeleton where they're not fused at all, and there are some parts where you can still see the join, but it's beginning to stitch together. So she's right on that borderline.
She's kind of a teenager.
Yeah, she would have been kind of an adolescent, yeah. The other way is to actually slice through her bones and look at the microstructure of the bone. Actually, it seems like in some birds and in lots of reptiles today and in dinosaurs, as they grew, they put down rings. So it looks almost like tree rings inside her bones. And whether or not they correlate exactly to years, that's still uncertain. But certainly the more rings you have in there, the older the animal. And Sophie does not have many rings in her bones. And also once animals either cease growing entirely or slow down markedly, you get a very distinct texture on the very outside surface of their bones, which shows that they've almost stopped growing. And Sophie doesn't have that, so she probably was still growing fairly rapidly. And what that means for body mass is that we then have to take into consideration the fact that, you know, a human baby does not have the exact same proportions as an adult, and the same is true of all animals. So you get this kind of what we call ontogenetic scaling, so a change in the bodily proportions, and we have to account for that when we estimate her body mass.
Do we have some things we can look at?
Sure, yeah, you can have a look.
So what have we got in here that belongs to her?
So everything that we have of Sophie is out on display for the public to see, apart from the skull. So the skull is one of the most exciting parts about Sophie because it's so complete. It's very fragile, and it's quite difficult to mount because there's so many bones. So it's these couple of boxes here I'll get out for you to have a look at.
Don't want you dropping any bits of
Let's not drop
multi-million-year-old dinosaur.
Go.
These look like the kind of boxes you might, you know, see wedding flowers or something in a cardboard box with a nice transparent lid, but they're full of brown fragments of bones. What sort of things have we got here?
So this box here is entirely composed of teeth. So these are all of her teeth, an incredible number. And what's really striking about them is how small they are, given the size of the animal. I mean, if you compared it to some of your big African mammals like rhinos and elephants, they've got, you know, big batteries of teeth, whereas these are incredibly small, and they don't look like they would have been particularly efficient at chewing or grinding. There's no obvious surfaces on them where you can see that they've been grinding their food.
They look like little nails or something.
Yes, yeah. I mean, they're smaller than all of your teeth, for sure. So what we think from this is that stegosaurs perhaps weren't chewing their food at all. Perhaps they were just plucking out vegetation from the ground and pretty much swallowing it whole. And that kind of agrees with what we see when we look at how she's reconstructed on display. She's got these big hips, very broad rib cage. So perhaps she had a kind of fermenting vat of a stomach in there, and she was just, you know, stewing all her food in there and not processing it in her mouth.
What about some of the other bits of her skull? These are all quite in pieces.
Yeah, so this is the big bit. This is the most exciting part. So this is...
eyeball, like eye sockets, is that?
Not quite eye sockets, no. So these are what we call fenestrae, or little kind of windows, which just kind of act to lighten the skull, and they act to as areas for muscles to attach onto. But this is where the brain would have sat, in here.
How big would that have been? They're notoriously small-brained dinosaurs, aren't they?
Kind of unfairly so, I think. So they have a reputation, stegosaurs in particular, of having very small brains. The often cited fact is about the size of a walnut. In the case of Sophie, we CT scan this with X-rays so we can see inside it. And it's actually about the size of a small plum, something like that. So still not vast.
Not vast for that size of animal.
No, but I mean, it really does all you need to do. I mean, even in the human brain, the actual area that's in control of, you know, moving and breathing and reproducing, you know, isn't huge. So, I mean, this was obviously good enough for stegosaurs to do what they needed to do. This is the area where the spinal cord would have gone in the back here.
Wow. That's incredible.
You can actually see her inner ears as well. When we reconstruct in the CT scan, in here would be the inner ear canals, so we can look at the shape of them. And other paleontologists from the shape of those canals have said things about perhaps what posture they hold their head in, or maybe what kind of range of sounds they could hear as well.
Can I touch it?
Yeah, sure. Yeah.
Wow.
155 million years old.
It's amazing. I love fossils. They have such a strange texture, almost like kind of heavy wood. That's sort of
so it's mineralized bone. Yeah. So there is still some geochemistry of the original bone there, but it is effectively, you know, a rock now. Other cool parts here, you can see these are where the teeth would have sat in the jaw.
So that's pockets for those nails.
Yeah. So that's part of the upper jaw there, and you can see they pointed pretty much straight down, whereas this is the lower jaw here. So this is where the hinge would be. And what's interesting about the lower jaw, you can see where the teeth fit in. They're actually kind of pointing in kind of sideways towards the tongue. They're not going straight up, which is very bizarre. So that's part of what we're looking at now, as to how she was managing to eat.
And is this giving you some clues as to the animals that came next after that?
So actually we think in stegosaurs it looks like they're almost on the way to becoming totally toothless. So we reconstruct them with having a kind of almost like a beak-like end to their mouth, and certainly by the looks of their teeth, they weren't really functioning for much at all. So perhaps in stegosaurs they were on their way to becoming totally lacking in teeth. Unfortunately, they didn't quite get there, as far as we know. We haven't found the specimen.
No toothless stegosaur out there?
There is, no, not at present. You never know, but no, not currently.
What's your favourite bit?
Of Sophie?
Yes.
Ooh, that's tough. I like her plates, obviously. Actually, I quite like her neck plates, so not the big showy ones on the top of her hips, but actually she's got a whole range of plates, the smaller ones that are actually coming down towards her head. And I think they're the most interesting, certainly in terms of the various ideas about what they were using their plates for, whether or not it was for protection or display or losing or gaining heat quickly. In my opinion, if you're going to protect any area of your body, you should be protecting your neck. Whereas actually we find very small plates on the neck and very large plates on our hips. So it seems something's not quite right there, and that's something we're looking at the moment. So yeah, I like the small plates.
Now that you've started to work this out about Sophie, about how much she might have weighed, what she looked like, what next? What do you still want to figure out about her?
So body mass is really fundamental from where we want to go from here. So in any kind of equation that I might use for, say, estimating how fast she might have moved, maybe reconstructing their metabolism, how much would they have to eat, all of those things, all of those equations and models require an estimate for body mass. So that's why we had to get this really nailed down very early on, and from that we can build upon this. So the thing that I'm working on now is beginning to strap muscles onto my 3D models, looking at how efficient some of her muscles would have been for moving her limbs, and then eventually reconstructing how she would have walked.
Real life walking with dinosaurs.
Exactly, yeah, you've got to get your information from somewhere, haven't you?
That's Charlotte Brassey from the Natural History Museum.